The University of St. Thomas is the largest private Catholic university in Minnesota. It has a population of about 11,000 students, and it includes the School of Engineering, which is where I teach. We have about 700 to 800 students in both undergraduate and graduate courses in engineering. We determined that the University of St. Thomas School of Engineering would need software such as ANSYS simulation software because our curriculum is focused on allowing students, or enabling students to solve real-world problems of practical interest. And to do that, we've got a curriculum which is very heavily focused on hands-on activities. And that includes not only working with real products, real hardware, but also simulating how those products will perform in a real-life environment. Our mission of instruction is multi-purpose, multifold. We have undergraduate students who are really training to become competent engineers. And for those students, we're introducing them to some of the tools that they're going to need to master out in the real world. We also have graduate courses in simulation, and I teach a number of those courses where working adults, people who are already working engineers, are coming and taking classes to complete a master's degree. And in their case, we're teaching them to use the ANSYS software to solve specific problems that they're facing in their work environment. I chose ANSYS as the software platform that we're using because it is the best at what I call multi-physics. That is, situations where you need to solve a structural problem which also has a fluid flow component which may involve some heat transfer. Or perhaps there's some electromagnetics which is causing some heating which then causes stresses. And ANSYS is the best software at integrating those different multi-physics together. One of the reasons why we've continued to use ANSYS in addition to its multi-physics capabilities is because it integrates efficiently with CAD packages. So we use SolidWorks. We teach our undergraduate students CAD through SolidWorks, and we are able to import geometries directly from SolidWorks into ANSYS without any problem. And that ease of interaction is a real advantage for ANSYS. Industry utilizes our experience with ANSYS in a number of ways. For example, industry will send students to take our graduate level course. And in that graduate level course, students learn how to use the software package, but then they solve a problem that industry is working on. As an example, a number of years ago, Boston Scientific had a recall of a stent device. And it turned out that the recall was related to a molding process in the stent manufacturing. A student in my class solved that problem and corrected that problem in the context of the course. And that's one of the ways that companies can learn how to use ANSYS and can reap the real benefits. There are many benefits to a student to use ANSYS software. And what I've discovered is that when students go through our courses and they become proficient in ANSYS, it opens up a whole class of problems that they can solve that they were otherwise unable to solve before. And that adds really real value to their career. It adds real value to their company. The ANSYS software presents a great value to our university and the School of Engineering because it attracts a very large number of students who are already working adults working in industry. And they recognize the value and the competence that they can gather through using ANSYS, and that reflects on the value of the School of Engineering. So our standing with industry has risen significantly because companies realize that we're teaching tools that they can use to solve problems that were otherwise unsolvable. For my own research activities, the real value in using ANSYS lies in the fact that ANSYS can solve problems that are otherwise unsolvable. I work at the cutting edge of fluid flow and fluid mechanics. I work on a frontier that doesn't have a wealth of literature and a wealth of knowledge. And I'm actually solving problems that no one in the world has ever solved using ANSYS. If I didn't have ANSYS in the classroom, I would be solving a lot of differential equations, and I would be working very hard to keep students awake during lecture.